Second Lieutenant Robert Samuel Johnson squeezed his control stick, his 47C Thunderbolt, flying at the rear of his squadron's formation at 28,000 feet. The 56th Fighter Group had crossed the English Channel minutes earlier. 48 Republic 47 Thunderbolts, flying escort for B-17 bombers, returning from striking Villers airfield near Paris. Johnson had scored his first victory just weeks earlier. He was 23 years old from Lawton, Oklahoma, still learning the brutal calculus of air combat over occupied Europe. After the son of a mechanic, Johnson had grown up poor during the Depression, earning his pilot's license the day before his 16th birthday by working odd jobs and saving every penny. Now he flew one of the largest, heaviest single-engine fighters ever built, 7 tons of metal and fury, powered by 18 cylinders of American engineering. The massive Pratt & Whitney R280 radial engine ahead of him produced 2,000 horsepower, turning a 13T propeller that could pull the Thunderbolt through the sky at over 400 mph. Then everything exploded. 16 Fowler-Wolf F-190 fighters from Jägerschwader 26, one of the Luftwaffe's most elite units, dove out of the sun from 32,000 ft. The first pass scattered the Thunderbolts. Johnson's aircraft Flying Tail and Charlie took the concentrated fire of multiple German fighters. 20 missiles tore into his fuselage. The canopy shattered. Hydraulic lines ruptured, spraying fluid across his face and into his eyes. Shrapnel from a cannon shell peppered his right leg. A machine gun bullet creased the tip of his nose. The engine caught fire. Johnson tried desperately to bail out, but discovered his canopy was jammed, damaged by cannon strikes. It would open only 6 in, not enough for him to squeeze through with his parachute. The fire went out on its own, starved of fuel by the ruptured lines. But Johnson was half-blind, his eyes swollen shut from hydraulic fluid burns, struggling to control an aircraft that had absorbed at least 21 direct 20 men for punning hits and more than 207.92 machine gun strikes. Any other fighter would have disintegrated. Most pilots would have been dead. Johnson and his Thunderbolt kept flying. This moment would become one of thousands that fundamentally altered how German fighter pilots understood American engineering philosophy. The Luftwaffe had been trained on aircraft that prioritized speed, maneuverability, elegant efficiency. Every gram of weight was scrutinized, every design choice optimized for performance. The Americans, it seemed, had built something entirely different. They had built a flying tank, and in that difference lay a revolution in fighter design that would influence aviation for generations to come. The German aces, the most skilled fighter pilots in the world, men who had shot down hundreds of Allied aircraft, were about to learn a humbling lesson. Skill and firepower meant nothing if your enemy simply refused to fall. The story of the 47 Thunderbolt is not just about an aircraft. It is about the collision of 2 engineering philosophies, 2 ways of thinking about survival, 2 approaches to warfare itself. And it begins with a simple, terrifying question that German pilots asked themselves after every encounter with this massive American fighter. Why won't it go down? The Republic 47 Thunderbolt entered service with the United States Army Air Forces in November 1942. At first glance, it seemed to violate every principle of fighter design that had been established in the first 3 years of the war. The 47D variant, the most common model, weighed 17,500 lb at maximum takeoff weight, making it the heaviest single-engine fighter of the conflict. By comparison, the Supermarine Spitfire weighed approximately 9,500 lb. The Messerschmitt Bf 109G weighed 7,500 pounds, and the Fowler-Wolf F-190 weighed 10,800 lb. The 47 was nearly twice the weight of Germany's most successful fighter. German intelligence officers analyzing photographs and reports from early encounters dismissed it as a mistake, a transitional design that would be quickly replaced. They were catastrophically wrong. The Thunderbolt was designed by Alexander Kartveli, a Georgian-born engineer who had immigrated to America in 1927 and joined the Republic Aviation Company, successor to Sevecki Aircraft. His design philosophy differed fundamentally from European approaches, where European designers obsessed over weight reduction, streamlining every component. cart fairly built for survivability above all else. The 47's airframe was constructed with unprecedented structural strength. The main wing spar was a single piece of forged aluminum, 4 in thick at its center, tapering to 2 in at the wing tips. This spar could withstand 12 G loads without failure, 3 times the force that would tear apart a Messerschmitt Bf 109. The fuselage was built around the massive Pratt & Whitney R2800 double wasp radial engine. But more importantly, the entire aircraft was surrounded by protective structures that would prove revolutionary. Between the engine and the pilot sat the turbocharger system, oil coolers, intercoolers, and most crucially, multiple fuel tanks with varying internal capacity by variant. Early 47B and C models carried 305 G internally. The bubble canopy 47D25 through D40 variants, the most common in combat, carried 370 G. Late war 47N variants for Pacific service carried an extraordinary 556 gall. Every gallon was stored in self-sealing tanks, a technology that would prove decisive. Self-sealing fuel tanks were not new. The British had developed them. The Americans had improved them. But the 47's implementation was unprecedented in its effectiveness. Each fuel cell was surrounded by multiple layers of rubber compound that would swell and seal when exposed to gasoline, closing bullet holes within seconds. German pilots discovered this the hard way. Attacks that would have sent any other fighter down in flames simply punched holes that sealed themselves. The 47 kept flying. The pilot protection extended far beyond fuel tanks. The pilot sat in what American ground crews affectionately called an armored bathtub, though the term understated its effectiveness. Substantial armor plating protected the pilot from virtually every angle. The seat was backed by face-hardened steel armor capable of stopping 20 Mustang rounds at close range. The headrest contained additional armor plating. Beneath the seat, another armor plate protected from ground fire during low-altitude attacks. In front, a thick bulletproof glass windscreen could stop even 30 man cannon shells. German pilots, accustomed to aircraft where armor was minimal to save weight, found themselves facing an opponent who could absorb hits that would kill them instantly. Major Heinz Baer, third highest scoring German ace with 220 victories across all fronts, would later describe his frustration in post-war interviews. The 47 could absorb an astounding amount of lead and had to be handled very carefully. We could hit them repeatedly with our cannon. We could see our rounds striking, but the pilot never fell. The Thunderbolt pilot could sit there absorbing our fire, waiting for his moment to return fire. It was psychological warfare. We knew we were hitting them, but they wouldn't die. The first major air battle that revealed the 47's extraordinary toughness occurred on that June afternoon in 1943. Robert Johnson's squadron had been jumped by Jägerschwadron 26, commanded by some of Germany's finest pilots. The tactics that had worked brilliantly against P-38 Lightnings and 40 Warhawks failed completely against the Thunderbolt. Johnson's badly damaged fighter plummeted initially, spinning toward Earth. Through enormous physical effort, fighting controls that barely responded, half-blind from hydraulic fluid burns, Johnson managed to level the wings and pull out of the dive. He turned northwest, nursing his crippled aircraft toward England at minimum speed, unable to see properly through his damaged canopy and burning eyes. Then a single F-190 appeared behind him. The German pilot, likely Ostleutnant Egon Meer of JG-2, one of the Luftwaffe's most successful bomber-destroyers with over 100 victories, closed in to finish off the straggler. Meer had expended his 20 Messerschmitt munition-destroying B-7s earlier in the mission, but his 7.92 machine gun still functioned. He made repeated passes, each time raking Johnson's Thunderbolt with accurate fire. Johnson could do nothing but slow his aircraft to just above stall speed and slew it left and right, making himself a harder target. He even fired back blindly during Meier's passes, though his compromised eyesight and damaged controls prevented accurate aim. Meier made pass after pass. Each time bullets struck Johnson's fighter, each time the 47 kept flying. After the third attack, Meier apparently ran out of ammunition entirely. According to Johnson's account, verified by his wingman, who caught up moments later. Mayer pulled alongside the battered Thunderbolt, close enough for Johnson to see him clearly. The German pilot looked at the devastated American fighter, still somehow flying, then waggled his wings in salute and turned back toward France. Johnson continued toward England, alone. He made it to RAF Manston in Kent, barely able to see the runway through his swollen eyes and the oil-covered windscreen. His landing gear miraculously still functioned. He touched down and rolled to a stop. Ground crews counted the damage in stunned silence. 21 direct 20-man hits, cannon hits. More than 27.922 machine gun strikes. The entire tail section was shredded. The canopy was destroyed. Control cables were severed. Hydraulic systems were demolished. The aircraft was declared beyond economical repair and used for spare parts, but Johnson walked away with relatively minor injuries. He would return to combat 5 days later. By the end of his tour in May 1944, he would score 27 aerial victories, becoming one of America's top aces and the first U.S. fighter pilot in Europe to surpass Edi Rickenbacker's World War I record of 26 kills. The significance of Johnson's survival extended far beyond one pilot's luck. The 56th Fighter Group's operations officer, Major David Schilling, recognized immediately that the P-47 survivability changed fundamental combat doctrine. In reports filed throughout the summer of 1943, now preserved in Air Force Historical Research Agency archives, 56th Fighter Group commanders documented a tactical revolution. American pilots could withstand punishment that would destroy any other fighter. This allowed aggressive tactics that would be suicidal in lighter aircraft. 47 pilots could pursue attacks longer, press home deflection shots that required flying through enemy fire, and most critically protect bombers by staying in combat rather than breaking off to avoid damage. The Thunderbolt didn't just survive. It allowed American pilots to fight differently. German fighter commanders quickly realized they faced a fundamental problem. Their entire tactical doctrine was built around energy fighting, using speed and altitude advantage to make slashing attacks, then escaping before the enemy could respond. Against the 47, this doctrine failed. The Thunderbolt could absorb the initial attack, then pursue, and in any extended combat, the 47's advantages became overwhelming. Its 8 Browning M250 caliber machine guns, while individually less powerful than German 20 mm or 30 mm cannons, fired at a combined rate of 1,200 rounds per minute. More importantly, the American machine guns were extraordinarily reliable, rarely jamming even in extended combat. German cannons frequently malfunctioned, leaving pilots defenseless at critical moments. By the summer of 1943, German tactical directives began reflecting this reality. Documents captured after the war revealed the Luftwaffe's growing concern. Fighter wings issued instructions emphasizing the need to achieve kills on the first attack pass. Pilots were explicitly warned not to assume visible strikes meant the aircraft was finished, not to assume fire or smoke meant imminent destruction, and not to remain in combat with damaged Thunderbolts that were often still fully capable of fighting. These directives represented a fundamental admission. The Luftwaffe's best pilots, flying aircraft they believed superior, were being told to avoid extended combat with American fighters. The impact on German morale was profound. The summer and fall of 1943 brought the strategic bombing campaign into full intensity. American B-17 and B-24 bombers struck deep into Germany, targeting aircraft factories, oil refineries, and ball-bearing plants. The 47 groups, now numbering multiple complete fighter groups with plans for many more, escorted the bombers. German fighter wings under desperate pressure to stop the bombers threw everything into the attacks. The results proved devastating for the Luftwaffe, not in terms of aircraft destroyed, but in terms of pilot morale and tactical effectiveness. Attacking bomber formations meant flying through fields of defensive fire from both bombers and escorts. The B-7's guns could damage fighters, but rarely destroyed them with single hits. The P-47's guns destroyed anything they hit. But more demoralizing was watching American fighters continue flying despite damage that should have been fatal. Major Gaural, fourth highest scoring ace in history, with 275 victories, flew most of his missions on the Eastern Front, where he was extraordinarily successful. He flew one mission against American bombers in the West in August 1943. He never flew against them again. In post-war interviews, he explained, "On the Eastern Front, if you hit a Russian fighter solidly, it went down. The LGG-3, the Yak-1, even the later models, they were fragile compared to Western fighters. In the West, I attacked a Thunderbolt from perfect position. I was close. I had time. I fired everything. I saw pieces flying off, strikes on the fuselage, the wings, the tail. The American never wavered. He turned on me and nearly shot me down. I told my commander I preferred to remain in the East. The mathematics were better." This sentiment became increasingly common among Luftwaffe pilots. The Eastern Front, despite being numerically more dangerous, was psychologically preferable. Russian fighters could be destroyed. American Thunderbolts seemed indestructible. The statistics supported this perception. During 1943, the 47 combat loss rate per sortie was 0.7% compared to 1.2% for Spitfires and 1.4% for P-38 Lightnings. More tellingly, of 47s that returned with battle damage, over 90% were repaired and returned to service within 1 week. The aircraft could be shot full of holes and keep flying. Then it could be patched and fly again the next day. The engineering philosophy behind this survivability became clearer as German intelligence gathered more information. Captured 47s were shipped to the Reclin testing facility in Germany, where Luftwaffe engineers conducted detailed examinations. Their reports discovered in German archives after the war revealed both admiration and frustration. German engineers noted that the 47 used materials and construction techniques that prioritized durability over minimum weight. Where German fighters used thin aluminum stampings riveted together with as few fasteners as possible, the 47 used thicker gauge aluminum with more robust fastening. Where German designs used single load paths for efficiency, the 47 featured redundant structures. If one spar was damaged, another could carry the load. If one control cable was severed, backup cables existed. The aircraft was designed on the assumption that it would be damaged in combat and needed to bring the pilot home anyway. One German technical report from late 1943 captured the philosophical difference. The American design is inefficient by our standards. They use substantially more material than necessary for basic structural integrity. They accept significant weight penalties for redundant systems. They sacrifice maneuverability for protection. Yet in operational terms, their philosophy is devastatingly effective. Their pilots survive to fly again. Our pilots in our lighter, more maneuverable fighters die in greater numbers. The Americans have solved a different problem than we have. We built fighters to win dogfights. They built fighters to win wars. This observation cut to the heart of the matter. German engineering excellence had produced aircraft of extraordinary performance. The B-109 was faster than the 47 at most altitudes below 25,000, 5,000. The F-190 could outturn it. The Mi-262 jet entering service in 1944 was faster than anything the Allies possessed. But performance meant nothing if the pilot didn't survive to use it. The 47's designers understood that fighter combat was ultimately about pilot survival. An experienced pilot in a less maneuverable but more survivable aircraft would defeat a novice in a high-performance aircraft. And critically, the survivable aircraft would produce more experienced pilots because they lived long enough to gain that experience. The fall of 1943 brought a new phase in the air war. Long-range escort missions pushed deeper into Germany. The 47, equipped with external drop tanks that could be jettisoned when empty, now had sufficient range to escort bombers to targets that had previously been beyond fighter protection. German fighter commanders faced an impossible situation. Pilots reported that destroying Thunderbolts required ammunition expenditure far beyond normal combat expectations. Most pilots fired their entire ammunition load at a single 47 without bringing it down. So this meant that even if they survived the encounter, they had to return to base without ammunition, unable to engage bombers or other fighters. Entire German fighter wings were being rendered combat ineffective, not by being shot down, but by being forced to waste ammunition on unkillable American escorts. General Major Adolf Galland. commander of all German fighter forces from November 1941 to January 1945, issued directives attempting to address this problem. In October 1943, he ordered pilots to ignore American fighters and focus exclusively on bombers. The theory was that bombers were the real threat. Fighters were just escorts and destroying the bombers would end the campaign. The directive failed catastrophically. American fighter pilots, freed from defensive concerns by their aircraft's survivability, became even more aggressive. They would dive on German formations, fly through initial defensive fire, then systematically destroy German fighters as they tried to attack bombers. First Lieutenant Francis Gabreski, flying with the 56th Fighter Group, became the embodiment of this aggressive philosophy. Gabreski, son of Polish immigrants, had personal motivation beyond military duty. His relatives still lived in Poland under Nazi occupation. He flew every mission as if it were personal vengeance. His tactics exploited the 47's strengths perfectly. He would identify German fighters attacking bombers, dive on them from above, withstand their defensive fire if they tried to turn on him, then destroy them with massed machine gun fire at close range. Between August 1943 and July 1944, Gabreski would shoot down 28 German aircraft, making him the top American ace in Europe. His survival through hundreds of combat missions, many seeing his aircraft badly damaged, became legendary. The winter of 1943 to 44 brought the most intense period of air combat in the European theater. Germany's aircraft industry was under relentless attack. Luftwaffe fighter strength, despite desperate production efforts, was being ground down by attrition. Experienced German pilots were being killed faster than they could be replaced. The 47 groups, meanwhile, were growing stronger. New pilot training in the United States emphasized the 47's survivability as a core teaching point. Instructor students explicitly, your aircraft can take damage that would destroy anything else. Use that advantage. Press your attacks. The Thunderbolt will get you home. Major Hubert Zehner, commander of the 56th Fighter Group, institutionalized this aggressive philosophy into formal tactics. The formation that became known as the Zeeman was designed to maximize the 47's strengths. Instead of traditional close formations that restricted maneuverability, Zeeman fighters flew in loose, flexible groups that could respond quickly to threats. When German fighters attacked, the 47's would not turn away defensively. Instead, they would turn into the attack, forcing head-on encounters where the 47's armor and firepower gave it overwhelming advantage. German pilots accustomed to enemies who would evade found themselves facing Americans who deliberately flew into their fire, absorbed it, then returned devastating fire of their own. By February 1944, the strategic situation had shifted dramatically. The P-51 Mustang, with even longer range, was beginning to supplement 47 groups, but the Thunderbolt remained the workhorse of bomber escort. Its survivability meant it could be used for the most dangerous missions. Initial penetration of German airspace, combat over heavily defended targets, suppression of German air bases. 51s were faster and more maneuverable, better suited for dogfighting. But when the mission required an aircraft that could absorb punishment and keep fighting, commanders chose the 47. Spring 1944 brought Operation Argument, the Big Week campaign designed to destroy German fighter production. Between February 20th and 25th, combined American and British forces launched the most intensive air campaign yet seen. The 8th Air Force in England and the 15th Air Force in Italy flew approximately 3,800 heavy bomber sorties, while Luftwaffe Command added over 2,800 night sorties. Approximately 10,000 tons of bombs struck German aircraft factories. The 47 groups bore the brunt of daylight fighter, escort duties. Over 500 German fighters were destroyed during the 6-day campaign. The P-47 loss rate remained under 1% per sortie. German pilots forced to defend their factories and airfields had no choice but to engage. They died in unprecedented numbers. After-action reports from German units following Big revealed growing demoralization. Pilots described hitting Thunderbolts repeatedly only to watch them continue fighting. Some German pilots began requesting transfers to other fronts. Others developed mechanical problems that kept them grounded. The Luftwaffe's personnel office investigated and discovered widespread reluctance to fly against American forces, specifically citing encounters with 47s. The summer of 1944 brought the 47 into a new role: ground attack. The Thunderbolt's ability to absorb damage made it ideal for low-altitude attacks on German positions. Unlike other fighters vulnerable to ground fire, the 47 could fly through intense anti-aircraft fire, deliver its payload, and return home with battle damage that would have destroyed lighter aircraft. Throughout June and July 1944, 47 groups flew thousands of ground attack sorties, supporting the Allied advance from Normandy. German ground forces came to dread the distinctive sound of the 47's radial engine. They called it JBO, short for Jagd Bomber or Fighter Bomber, but the term carried fear rather than simple description. Second Lieutenant Robert Harmon, flying with the 362nd Fighter Group, was attacking German positions near St. Lo on July 25th when multiple 37 anti-aircraft shells struck his aircraft. One shell destroyed his right-wing tip, removing several feet of structure. Another penetrated his engine, destroying 2 cylinders and briefly setting the engine on fire. A third struck his tail, severing elevator control cables. Harmon managed to extinguish the fire using engine shutdown and restart procedures. He regained partial control using trim tabs alone, compensating for the severed cables. He flew his crippled aircraft 150 miles back to his base in England on an engine running on 16 of 18 cylinders. The aircraft was deemed beyond repair and used for spare parts, but Harmon walked away without injury. He would fly 89 more combat missions before war's end. Ground crews developed dark humor about the damage. They joked that the 47 only needed 3 things to fly: an engine running on at least half its cylinders, at least one aileron working, and a pilot with the guts to fly it. The jokes reflected a deeper truth. The aircraft's toughness had become so expected that anything less than catastrophic damage was considered routine. German anti-aircraft crews, equipped with 20 B-7 and 88 mm guns, discovered that bringing down a 47 required far more hits than any other Allied aircraft. Standard doctrine assumed 2 or 3 20 hits would destroy a fighter. Against the 47, crews reported needing 10 or more direct hits, and even then, the aircraft often made it back to Allied territory. The 47's radial engine was particularly difficult to stop. Unlike inline engines where a single cooling system hit caused rapid failure, the radial could lose entire cylinders and continue running. American pilots reported flying home on engines missing 3 or 4 cylinders, still producing enough power to maintain altitude. In the Pacific Theater, the 47 served with distinction from 1943 through war's end. The long-range 47N variant, with its 556-gal internal fuel capacity and wet-wing design, allowing 1266 gal total with external tanks, was specifically developed for Pacific operations. These aircraft escorted B-29 Superfortress bombers on raids against Japan and provided ground support throughout the island hopping campaign. The P-47's ruggedness proved equally valuable against Japanese fighters and anti-aircraft fire. The 318th Fighter Group, operating 47s from Ashima near Okinawa, flew some of the longest fighter escort missions in history, over 1,500 m to targets in Japan and back. The aircraft's ability to absorb battle damage and continue flying was as crucial in the Pacific as it had been in Europe. The final major air battle of the European theater occurred on January 1st, 1945. Operation Bodenplatte, a desperate German attempt to destroy Allied air power on the ground. The Luftwaffe launched over 850 fighters in coordinated strikes against Allied airfields in Belgium and Holland. The operation achieved some initial success, destroying 305 Allied aircraft on the ground and damaging another 190, but as Allied fighters scrambled and engaged, the results were catastrophic for the Germans. The battle lasted most of the day, sprawling across hundreds of square miles. By evening, The Luftwaffe had lost 271 aircraft destroyed with 143 pilots killed or missing, including 3 Gunner Commodore, 5 Gruppenkommandeur, and 14 Staffelkapitän. The loss of experienced leadership was irreplaceable. 47 groups engaged throughout the day lost aircraft primarily to ground fire during initial German strafing attacks. Not one P-47 was lost in air-to-air combat, despite being outnumbered in many engagements. German pilots returning from Bodenplatte reported the same frustrating experience they had suffered throughout the war. They would hit 47s repeatedly, see visible damage, yet watch the American fighters continue fighting. Major Guard Barkhorn, second highest scoring ace in history, with 301 victories, all on the Eastern Front, participated in Bodenplatte. In post-war interviews, he described shooting at 147 with his entire ammunition load, seeing numerous strikes, yet the aircraft continued flying until he finally hit a critical component. He noted that with the same ammunition on the Eastern Front, he could have shot down 5 Russian fighters. The war ended in May 1945. The final accounting showed the P-47's extraordinary success. Over 15,683 47s were built during the war, more than any other American fighter, except the P-51 Mustang. 47s flew 546,000 combat sorties in the European and Mediterranean theaters. They were credited with destroying 3,752 enemy aircraft in air-to-air combat, plus approximately 3,000 more on the ground for a combined total of about 7,000 enemy aircraft destroyed. They also destroyed 9,000 locomotives, 86,000 railroad cars, and 6,000 armored vehicles in ground attack missions. But most importantly, the 47's loss rate per sortie was the lowest of any American fighter, 0.7% in the European theater. For every 1,000 sorties flown, only 7 47s were lost. By comparison, the P-38 Lightning lost 13 per 0, the P-51 Mustang per 1,000. 9 per 1,000. The 47's survivability translated directly into pilot survival. Of American aviators who served in Europe, those flying P-47s had the highest survival rate of any fighter pilots. This wasn't just a statistical anomaly. It represented thousands of young men who came home to their families instead of dying over Germany. The engineering decisions that made the 47 tough were also humanitarian decisions, though the engineers probably never framed them that way. German aces interviewed after the war uniformly expressed respect bordering on awe for the Thunderbolt's toughness. When aviation historians asked General Lieutenant Adolf Galland in post-war interviews what Allied aircraft he most respected, his answer was immediate and consistent. The 47 Thunderbolt, not because it was the best fighter aerodynamically. The P-51 was faster and more maneuverable. The Spitfire was more elegant. But the Thunderbolt was nearly unkillable. You could hit it and hit it and hit it, and it would keep coming. That was psychological defeat, knowing that your best shots might not be enough. Oberst Johannes Steinhoff, 176 victory ace, who survived the war despite being shot down multiple times, provided perhaps the most eloquent summary in his 1970 memoir. We learned to respect all our opponents. The Russian pilots for their courage, the British for their determination, the Americans for their numbers, but we feared the 47 specifically. It represented American industrial might in tangible form. It was the equivalent of a flying fortress, a machine so overbuilt, so excessive in its protection that it defied our conception of what a fighter should be. We flew graceful, efficient, deadly machines. They flew armored fortresses, and in the end, their fortresses defeated our thoroughbred ads. The technical data supported these subjective impressions. Post-war analysis by the United States Strategic Bombing Survey examined thousands of combat reports, damage assessments, and aircraft recovery records. Their findings quantified what German pilots had experienced firsthand. While specific hit-to-kill ratios varied by ammunition type and impact location, the P-47 consistently required far more hits to bring down than other Allied fighters. German pilots expended more ammunition per 47 destroyed than for any other Allied fighter type. This explains German frustration perfectly. Their aircraft carried limited ammunition, typically 200 rounds per 20 mm cannon and 1,000 rounds per machine gun. A single combat sortie might encounter multiple American fighters. Expending most or all ammunition on 147 left them defenseless against others. The engineering analysis revealed the specific features that created this toughness. When they appear at air shows, aging veterans sometimes attend. Men now in their 90s who flew the aircraft 80 years ago. They stand beside the massive fighters running their hands over the aluminum skin, remembering missions, remembering friends who didn't come home, remembering the aircraft that saved their lives. German veterans occasionally attend these same shows. Men who once tried to shoot down these aircraft, now united with their former enemies in old age. The conversations between them are remarkable. The Americans thank the Germans for their courage and skill. The Germans thank the Americans for treating prisoners with dignity. And both groups acknowledge the aircraft that stands between them, the flying fortress that proved tough enough to absorb everything the Luftwaffe could throw at it and still brought its pilots home. Oh, the legacy lives on in every fighter aircraft that prioritizes pilot survival, in every design that chooses protection over pure performance. The 47 proved that the best fighter is not the one that wins dogfights through superior performance, but the one that wins wars by keeping pilots alive. The German aces learned this lesson the hard way, pouring cannon fire into American fighters that wouldn't fall, watching their tactical advantages dissolve against an enemy that would not be stopped. In the end, that was the Thunderbolt's greatest weapon. Not its 8 machine guns, not its speed, not its structural strength, but its absolute refusal to quit. It was a fighter that matched the spirit of the nation that built it, a machine that embodied the determination that won the war. The German aces shot it full of holes, and it kept flying. That simple fact decided the outcome of the air war over Europe. The P-47 Thunderbolt was not the fastest fighter, not the most maneuverable, not the longest ranged, but it was the toughest, and in the brutal mathematics of aerial combat, toughness was the quality that mattered most. The German aces admitted as much, even as it cost them the war. Their admission stands as the ultimate testament to American engineering, to Alexander Kartvel's vision, and to the flying fortress that refused to poo-poo.